In this video, I will go over a copy of the final exam preparation quiz. The first question on the final exam is going to be the honesty statement, and you want to make sure you read that carefully and understand that you can't use any other materials during the exam other than those that are provided within the exam. So let's go through the questions. The first question, the minimum number of points needed to graph an equation is, and of course we know the answer to that is you need at least 2 points. The minimum number is 2. Question number 3, we want to find the coordinates of the point shown on the graph there. So remember, we start on the x-axis from the origin. We're moving over 2 points to the right here, and then we're going up 5 points. So this is 2, 5. And remember, when you write an ordered pair, you need to have those parentheses around it. Determine which ordered pairs satisfy the given equation. And I wanted to mention, I have some detailed solutions for some of the questions because it involves a little bit more work than I can show you on just the copy of the prep quiz. So you'll have a second handout to look at. And if we go back up to the top here, here's that problem number 4. And what I'm going to do is take each of those points and put it into the equation and see if I get a true statement. So for the first point, 14, 1, if you notice, I put it down here. So 14 plus 4 times 1 gives me 18. So that's a good answer. 14 and 1 is correct. Trying to get my pen to work for me. That's one answer. The second point, 2, 4, is also satisfying the equation. However, the third point, 0, -1, when I put that into the left side of the equation, I actually get -4, and that doesn't equal 18, so that's not a correct answer. So there's 2 answers for this, B and C. Question number 5 is a graphing question. So if we look at the equation, we see that the y-intercept is 0, -3. Go ahead and write that here, 0, -3, because the equation is in slope-intercept form. So that means I can eliminate graph A because that doesn't go through 0, -3. The other 3 graphs do. I notice it has a positive slope because the slope in this case is 1, coefficient on the x. So I can eliminate graph D because it's got a negative slope. Now if I take a look at graphs B and C, if I notice in graph B, y is going up by 2 while x is the rise is 2 and the run is 1, so B is not the correct answer, C is the correct answer. Determine the slope of the point that connects a line that connects the 2 points. And remember the equation for slope. I'm going to say, for instance, this is point number 1 and this is point number 2, and remember the formula y2 minus y1, I'm shown here in the numerator. -7 minus -2 gives me -5. And then x2 minus x1 in the denominator gives me 14, and there's the slope of my line, -5 over 14. For question number 7, they want me to find the equation of the line from the graph. And I noticed that the graph goes through the origin, 0, 0. So there is really the y-intercept is just 0, 0. And I notice it's a negative slope, so I can eliminate the answers that have positive slopes in them. Get that back into the thing here. This is a positive slope here. It can't be this one, and it can't be this one. So I'm left with C and D, and remember rise over run. And so in this case, the rise is actually going to be negative. So if I start from the origin, in order to get to another point on the line, I can go down 2 and over 1, so the slope is actually -2, and the correct answer here is C. Okay, number 8, I'm going to go over to the detailed solutions. And this is an interest problem. When $5,400 is investing in a savings account, paying simple interest for the year, we've got it given us an equation, I equals 5,400 times the rate, where R is the interest rate. They want you to graph it, but they actually just want to find out how much interest is earned. So we're going to take 5,400 times the interest rate times 1 year, and we get an answer of $540. A blank is a special type of relation where each value of the independent variable corresponds to a unique value of the dependent variable, and that's what we know as a function. Determine if the graph is a graph of a function. Remember the vertical line test. If I can drop a vertical line and it only crosses through the graph of the function one time, or graph of the relationship one time, it's a function, so this is a function. Evaluate the function for the given value of x And we want to know x equals 4 for the function x plus 1, and that's a pretty simple one. It's just going to be f of 4 equals 5. Okay, number 12, I've got a detailed solution for this one. Now, in the problem here, they tell us that Marco hired a plumber for 5 hours and the total cost was $170. So I've got some information here, and then it also says if he hired the same plumber for 11 hours, the cost would be $350, assuming a linear relationship. So I've got 2 points on the line now, 5, 170 and 11, 350. And I can find the slope of the line that connects those 2 points using the slope formula shown here, and the slope comes out to be 30. Now, what you could do, if you don't want to use this point slope formula, you could see which of the equations those points satisfy. That's one solution, but I'm going to use the point slope formula, and I've gotten the slope of 30, and I'm going to use the point 5, 170. And if you remember, the point slope formula is y minus the y coordinate of the point I picked, which here is 170, equals to 30, which is the slope, times x minus the x coordinate of the point I've selected, which is 5. And if I go ahead and simplify on the, distribute on the right side and then add 170, I come up with y equals 30x plus 20. And I could check and make sure that both of these points here that I identified up here actually are satisfying that equation. And number 13, we need to have a detailed solution for this one also. Suppose the sales of a particular brand of appliance are modeled by the linear function s of x equals 140x plus 3100, where s of x represents the number of sales in the year with x equals 0 corresponding to the year 2010. Find the number of sales expected in 2021 if the trend continues. So we need to determine the number of years from 2010 to 2021, and that's actually 11 years. And then we're going to evaluate the function when x equals 11. And when I do that, I come out with $4,640. So the correct answer here is A. And continuing over here with number 14, an exponential function given to me here, and they want us to find the function, determine the population in the year 0. Remember, in the year 0, the exponent of 0 is going to make that portion over here, right here, become 1, and so therefore the population in year 0 is going to be 48.45 million. So I can actually eliminate answers B and D because they don't have the correct starting population. And then in, what did they ask me? In 21 years, I went ahead and replaced x with 21 and simplified, did my exponent first, and then multiplied by the 48.45, and I get 74.96. And the correct answer here is C. A sequence of adjacent vertices and the edges connecting them is called and that's a path. This one wants you to create a graph that models the picture shown there. It's a layout of a city, and if we notice in the center of the city right here, and then it's being connected all different ways there through connections here and so forth. And so the correct answer here is going to be the one on the left side. Determine if the graph is connected or disconnected. Connected means there's a path between every pair of vertices, and this is a connected graph. A connected graph is shown below. Identify any bridges. So remember, a bridge is an edge. If we remove it, creates a disconnected graph. And if you notice in the center of the graph here, the edge EF is a bridge. If I take EF out, I'll create a disconnected bridge. I'm sorry, disconnected graph, not bridge. A path that passes through each edge of a graph exactly once is called and that's a Euler path. Using the following graph, find a Euler circuit. Remember, a circuit has to start and stop at the same vertex. So right away, I can eliminate A. And if I take a look here, if you try to do B, you'll see that B is not going to work out. It's actually going to be answer C, and I'll let you verify that on your own. And then in this one, we want a Euler path that starts with vertex D. Now, in this possible answers here, first of all, C is not, let's see, let's take a look here. This one goes from A to B twice, this one here. This is not the correct answer, because remember, in a Euler, You can't go through the same edge twice. And the same thing happens on C. Let me see. C goes, the correct answer is D, and I'm trying to remember why C is not correct, but it's not correct because I think there's one here where it's trying to connect something that doesn't connect. But the correct answer there is D. I'll let you verify that one on your own. Number 22, every complete graph has a Hamilton circuit, but not necessarily a Euler circuit. Find two different Hamilton circuits for the given graph. All right, so let's take a look here. As I look through these, the correct answer is A, but I want to show you some of the reasons why some of the others are eliminated. For instance, here in C, they're showing a connection here from A to F, which doesn't exist, so you can't use that one. And remember, we're doing circuits here, and so circuits, remember, we have to start and stop at the same vertex, and if you take a look, I'll let you verify here. The correct answer is A, but I'll let you verify that D is not correct, but the correct answer is A. 24, find two different Hamilton paths for the given graph. And again, I'll let you verify this one on your own, but the correct answer here is A. Number 25, we've got Kristen living in Florence, and she wants to visit relatives in 3 other cities. How many ways can she do that? And so if you remember here, this has got n equals 4. And the number of Hamilton circuits was n minus 1 factorial. In this case, that will be 3 factorial, which works out to be 6. So there's 6 different ways that she could do that. Okay, the next one I have a detailed solution for. And I actually created a pretty crude little graph here. So Mark lives in Tulsa, and he plans to attend graduate school in chemistry, and he wants to visit 3 different schools: Berkeley, California, Madison, and Chicago. And then he gives the cost of the flights. And so I went ahead and created the graph down below. And remember, he's going to start in Tulsa because that's where he lives. And there are 4 cities. So just like on the last problem we did with Kristen, there's going to be 6 different Hamilton, I should say circuits, not paths. And I went ahead and calculated the cost of each of those. So the first one, I went from Tulsa to Berkeley. This is basically going around the outside of the rectangle, and the cost of that is $9.12, and you can reverse it and get the same cost. And then I started with Tulsa, went to Chicago, to Berkeley, Madison, Tulsa, and that's $25.18, and then reverse it. And then finally Tulsa to Chicago, Madison, Berkeley, Tulsa. And so the lowest cost actually comes out to be going around the edges up here, and it's $19.12. And that was number 26, okay. The least expensive spanning tree of all spanning trees under consideration is called the minimum cost. And we're going to use a tree to model the parent-child relationships in the following problem. So Patty has 3 children, and we see that each of the graphs shows 3 children. Sherry has 1 child, and Sherry's in the left in all the pictures, and we can eliminate this one because this doesn't show Sherry having a child. This one looks like it's a little unusual. It shows Sherry sharing a child with another sister. And then Lulu has 1 child, and Kevin has 1 child. So the correct answer here must be A. Each of her children has 1 child. So the correct answer is going to be A. Determine a spanning tree from the graph to the right. So remember, spanning tree, you keep taking out those edges until you still have a connected graph. And so the correct answer here is going to be A. And here's another relationship one. And again, you can read through these. These are pretty easy. The answer for this one is D. I'll let you figure that one out. That's a pretty simple one. Okay, this problem here, we are looking at building a trail. And remember, when we create the minimum cost spanning tree, what do? We start with the shortest one, and the shortest one here happens to be 52. So we're going to go from B to D, which is a $52 one. And we want to make sure that that's included everywhere. And I don't see that included in D, so I can eliminate D. And that's the 52. And then the next shortest one is actually the 131, which is A to E. 131. So now I've got a 52 and a 131. Let's take a look at our pictures and see if we can eliminate anything. So I've got it on We don't have it on A. We can eliminate A. So we're basically going between B and C. And then A to E, and then next is A to C. A to C, which is 134. And then finally A to B, which is 154. Whoops. And so the correct graph we're going to use here is C. And that's got those 4 values written on there. And if you add up those miles there, the total miles covered is 471. And then if you multiply by that price per mile, you come up with a pretty hefty cost. It's $1,742,000. So pretty hefty cost. Let me erase this extra comma in there. So this was the total miles based on the graph, and then the total cost there was 140. Oh, I have an extra 0 here, don't I? Let me get rid of this one. Whoops. There we go. That's better. So it's $1.742 million. The voting method that may involve a series of elections or eliminations using a preference table until a candidate receives a majority of the votes is called the plurality with elimination method. Okay, the next question says, determine the winner using plurality and if they received a majority of the votes. So we notice there's 29 votes total if I add up the number of votes at the top. 29 votes total. Jones wins because he has 11, or she has 11 first choice votes. That's the plurality, but not the majority. So the correct answer here is D. Okay, this one we're going to do with plurality with elimination, and I've got a detailed solution for this one in number 34. All right, so there's 81 votes altogether, and in the first choice votes, we see A has 36, B 29, C 10, and D 6. A has a plurality, but not a majority, so we're going to eliminate D, and here's my updated preference table. Now A has 42 first place votes, but again, still not a majority, so we're going to eliminate C. And now A has 52 votes, a majority, and wins, so the answer here is going to be A. And we'll stay over here for the next one, which is number 35. 13 members of the executive committee of the Student Senate must vote for a representative for the College Board of Trustees among 3 candidates. And we want to do the board account method. So there's 3 candidates, so first choice votes are 3 points, second choice 2, and third choice 1 point. So for Greenberg, if my calculations are right, she had 5 first place votes, gives 15 points. For second place is 8. For third choice, and that gives 27 points. By a similar process, Haskins has 24 points, and Vasquez has 27 points. So there's actually no winner. There's a tie between Vasquez and Greenberg, rather. So the correct answer is A. And then continuing down, on this one, we're going to do the pairwise comparison method, and we have 4 locations, so there's going to be 6 comparisons using that formula for the number of comparisons, which is n times n minus 1 over 2. Oops. And so I went ahead and I did the comparisons down here. You can check my calculations here, but I came up with Alaska with 2 points, San Antonio 1 point, Florida 1 point, Hawaii 2 points. So we've got a tie between Hawaii and Alaska. Correct answer is D. Okay, number 37. If a candidate is favored when compared separately with every other candidate in an election, and then that candidate should be declared the winner. And this is called, which criterion is this called? And this is called the head-to-head criterion. And the mathematics department is holding an election for department chair, and here's the votes if the board account is used. Let's go over to the detailed solution for this one. So if I use board account on the table, and again, you can go in and check my calculations here, I come up with Smith winning, but Smith did not have a majority of first place votes, so the majority criterion is not satisfied. And then number 39, suppose plurality is used, and then if B drops out, determine if the irrelevant alternatives criterion is satisfied. Okay, so if B, let's do the plurality first, and we see that A would win because A has 7 votes. And then if B drops out, oh, I'm sorry, this should have been if B drops out, so this should be C. I don't think it changes the table here. Hold on a second, I messed this one up. B drops out, this would be a C. B drops out. Yeah, this would be a C. Sorry, so C wins. And so the irrelevant alternatives criterion is not satisfied because now we have a different winner. The original winner does not maintain. That was number 39. All right, let's go back over here. The population under consideration divided by the number of items to be allocated is called the standard divisor. And we want to find a standard divisor here for one of the, just a standard divisor overall, I'm sorry. So the total population here is 1569 if you add up the population numbers for the different schools, and then divide by the number of items to be allocated, and you'll come up with 41.289, which is answer A. Let's see, in this one we want to find the modified quota for the 6th precinct using the divisor 513. And so basically all you do here is take, for district number 6, 4027, divide by 513, and you'll come up with 7.8499, which is answer B. So you're just doing one of the precincts that time. Okay, for number 43, I have a detailed solution over here. So they want us to do Hamilton's apportionment here. So the total enrollment of the schools is 14,410. And if I divide that by 300 computers, I get a standard divisor of 34.7. And here's my table down here below. I took each of the school enrollments divided by the standard divisor to get the standard quota, rounded down. Notice here, I had only 298, so I had 2 extra computers to allocate, and I gave them to the schools with the largest decimal portion on theirs, which was school B and school A. And there's my final apportionment shown down there. Number 44, we're going to do Jefferson's method, and they're giving us a tip here to use a divisor between 13 and 14. The standard divisor, the total number of rooms is 600, and we're allocating 44 umbrellas, is 13.63. So I just took a shot at using 13.2, and I've got my modified quotas here. We always round down, and actually that worked out. So there's the answer for that one. It's number 44. All right, number 45. When A loses an item or items to group B, even though A's population grew at a faster rate than B's population, this is known as which paradox? And this is called the population paradox. And we're going to look at now an Alabama paradox. So let's go over to the detailed solutions for number 46. So we're going to increase, we're going to see if the Alabama paradox occurs if we increase the number of seats to from 160 to 161. So I did the initial allocation here using Hamilton. You can check my calculations. And then the standard quota changed slightly when we had one more seat. And then here's my new allocations. And no state lost a seat when one additional seat was added. So therefore, it didn't occur. The extra seat actually went here to F. But none of the other states lost a seat, so the Alabama paradox does not occur. And then finally, one last one, and we're going to look here for that population paradox. And so we're going to allocate here, first using Hamilton's method in 1998. And here's my apportionments here, 6, 5, and 2. And then I went to 1999. The population rose from 2083 up to 2146, so my standard divisor changed slightly. And here's my Hamilton apportionments here. And then what I'm going to look at is how was the growth rate for each of the precincts. So precinct 1 went from 930 to 975, grew at a rate about 40.8%. It maintained the number of seats. Now, if you notice, precinct 3 gained a seat. Precinct 2 did not. So let's look at the difference here. Precinct 2 grew at 1.6%. Precinct 3 actually grew at a slightly slower rate. So the actual population paradox did occur in this particular situation.